Good day all. Welcome to the next video in which I'll be having a look at the conversion from decimal to binary and vice versa. There are two formulas, functions in Excel, the Dec to bin and the bin to Dec, which is the decimal to binary conversion and the binary to decimal conversion. The problem with these functions in Excel is that it only goes up to 511, so you can't convert big numbers. Let me explain the restrictions at this point in time. In the top block here, I have a visual representation of our decimal system. Decimal, this means 10, as in the word decade. And the word 10, or should I say DEC, is based on a number of items that can go into one position. So it starts off with a naught, meaning there is nothing in the units. If we add a 1, it means that there is now one unit. Whatever unit we're talking about, we can talk about lights or batteries or computers or people. We are now talking about one person. Add another one and we have 2. So in the units field you can see that that increases as we add new items. Stones, cars, anything that we are counting, and that would go up by 1 unit. But please note that there can only be one item in the position of units. So if I go further, now we have 4, 5, 6, 7, 8. If I add one more, the unit is full. We have had 10 units. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, starting with naught up to the number 9. That is 10 units that we've put into that position. Once that unit has been filled, we use the next digit to say what we now call 10. We have filled the unit once. That is what the tens digit means. So we are now in the position of the tens, and I can continue there. Now we have filled, in this place we have filled that box twice, and I can do it 3 times, and so forth, until that 2 becomes to 9, and then we would have to go over to the next box, which is the digit for hundreds. And if I put a 1 in there, it tells me that I've filled the 10 box once, and I've filled the unit box 3 times already. And then we can go on. So now I have 2 units, 3 times tens. So I have filled the unit box 3 times, and I have filled the 10 box once. Now I have filled the 10 box twice, and we can continue with the thousands. So I've filled the 100 box once, the 10 box twice, and the unit 3 times. And inside the unit I now have 2 items that, so if we were counting cars, we have 2 cars or 2 stones or 2 batteries or whatever we are counting. That is how the decimal system works. So the most right digit is the least significant, and as we go up we have the tens, the hundreds and the thousands and so on. So we can have the 10,000s and the 100,000s and the millions. So too do we have that in the binary system. Now binary, bi means two, as in the word bicycle. Bicycle means two cycles, two wheels. And binary is the system where we count, same as in the decimal system. We can only have two items in one box. So it can be a naught or a 1. So if I fill this box with a 1, sorry, wrong box, then I have one item, but now it's full. I can't put more. So as in the decimal system, we would, if I add another one, this would become a naught and this would become a 1, which means I have filled this box once. And this is now available again. This is now naught, so I've got another position available, and I can put another 1 in there. I now have a 1 and a 2, which is 2 plus 1 is a 3. Please note that in L19 I have converted the binary into decimal. And the numbers that I use is first is 2 to the power of naught. Anything to the power of naught is 1. So I can have a naught or a 1. The maximum one here is a 1. So 2. The next one is 2 to the power of 1, which is 2. And 2 to the power of 3 is 4. And 2 to the power, 2 to the power of 2 is 4. 2 to the power of 3 is 8. And so we continue. So it is multiple of 2 every time we move to the left. 2 times 8 is 16, 2 times 16 32, and 2 times 32 64, and then 128, and so forth. So we continue that process. Now why has Excel stopped at 511? Because they go and add and I only go to 255. So if I would put another one, that would be 511. So a full byte in this case is 255, and including the naught is 256. Here at the bottom in the orange, this field B23, I have taken all the digits, all the ones or noughts, whatever I select, and put them together. Here they are separately. So there is 1 of the value of 128, 1 of the value of 64. If I make that a naught, we would not have a 64. So we would not have a power of 2 to the power of naught, 1, 2, 3, 4, 5, and 6. We don't have a 2 to the power of 6 in this case, which in decimal terms would be 64. And here in the position 1, 2, 3, 4, 5, 6, and 7, I can only have, as mentioned, a naught or a 1. It is now naught, which means I do not have the value of 64, 2 to the power of 6, because it's to the power of naught, to the power of 1, 2, 3, 4, 5, 6. 2 to the power of 6 is 64. And at the top I have taken the decimal values, and in L19 I have added them all up. So if we have, like in these cases, I have a 1, I have a 2, which is 3, I have a 4, which is 7, I have a 1 in the 8, which is 8, I have a 15, plus 16, plus 32, plus nothing, plus 128, which comes to 191. If I take this away, I have 63, which is 32 plus 16 plus 8 plus 4 plus 2 plus 1. And so does the binary system work. So for each one, I can for each place, I can put a 0 or a 1. Now it's 63. If I take the first value out, I have an even number. So because the first position is either a 0 or a 1, if I have a 1 in that position, I get odd numbers. So the decimal system, the binary system is built up of 2 to the power of either 1, 2, 3, 4, 5, 6, and it goes on as we go more to the right. Same in the decimal system, where we have 10, so units of 10, hundreds, thousands, 10,000s, and as we go further along, we get more and more or bigger numbers. And that is exactly how the binary system and the decimal system work. They work from the least significant number to the most significant number. And the formulas, so now the formulas to use to convert, I can go from decimal to binary. So I can put any, let's put a number, let's put 12, and I want to convert that, so I use decimal to binary. There's the function that I want to use, so I press tab. I have selected it, it is selected, I press tab, and there it is. And then I say I want to convert this number, and the decimal number 12 converts to 1100. Do not get into the habit of calling this 1100, because that would be in the decimal system. So if I write that same number in here, that is a 0, I would also get 12. So the decimal conversion is 12. But the binary number is 1100 binary. To go the other way around, I can, and now let's use a different number. Let's put a 1 in here and a 1 in there. I get 30. And the number, or the decimal, the binary value that I have is 11110. And now I'm going to convert that to, and now I must use binary to decimal. That is the one I want to use. I go tab to select the function, and I give it that number. Select the number I want to convert and press enter. And as we saw down in the conversion that I've built here, that is 30. So any number any binary number that I have will go in here. The problem as I mentioned, is that Excel only goes up to 511, which gives you 1, 2, 3, 4, 5, 6, 7, 8, 9 ones. The minute I go over, so I put 512, I get an error. And that is the downfall, or the limitations that we have in Excel. So 511 is the largest number we can have for a conversion from decimal to binary, and the same in the conversion from binary to decimal. So if I go 1, 2, 3, 4, 5, 6, 7, 8, 9, I get 512. But the minute I put an extra digit in there, so I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I will have it is not really an error. That's in this video I'm not going to go into that, but we have positive and negative numbers. So if I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, that will cause an error, because the most significant digit will show the positive or negative if we have so many digits. But at this point in time, that goes beyond this video, and maybe in later videos I will explain the positive and negative numbers in the conversion of decimal to binary and binary to decimal, and for now I'm just going to keep that the number that I showed is all these notes, so all these notes being 1, 2, 3, 4, 5 and one more, and there is 255. So that number that you see is this number, but any combination is an indication of the position from the right, the least significant, to the left, the most significant. So if I have 1, 0, 0, 0, 0, 1, I only have 1, 2, 3, 4, 5, 6, which is 2 to the power of 5 is the highest, because 2 to the power of 0 is the first one, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, and 6. 0, 1, 2, 3, 4, 5. Sorry, 5. I made a mistake. 2 to the power of 5 is 16 by the looks of it. 0, 1, 2, 3, 4, 5. Sorry, 32. Obviously, because that's 30. If I take the 0, if I replace the least significant to a 0, we'll make it an even number, and it will be 32. And that is for the function decimal to binary and binary to decimal, with the restrictions as I have mentioned. In the next video, I'm going to explain how we're going to convert binary to hexadecimal, or in the same manner decimal to hexadecimal. And for that we're going to be needing, if you look, we've got 8 digits in this case, and 8 digits is what we call a byte, and a byte is 1 digit, which means a binary digit, a bit, 1 bit, and we got 8 bits, and that is a byte. And once we start converting binary to hexadecimal, we're going to take 1 byte and divide it into 2 and get 4 bits, which is a nibble. So in 1 byte we have 2 nibbles, and 1 nibble makes up 1 character in the hexadecimal system. But I'll explain that in one of the next videos. For now, thank you very much, and see you in the next video. Goodbye.